Hello, here's a demonstration of an MEI question covering area. Doing the calculations of the area using integration, and I'm using the MEI June question 9 part 2 as an example. Part 1 of this question took us through finding the area using the trapezium rule, and they quite typically in section B will have one part on the trapezium rule and then one part carrying out the same task using integration. In this case, the whole thing is built around a farmer digging ditches, and we've got the cross section of a ditch. So let's, as ever, let's have a read of the question and see what they're asking of us. Part 2, another ditch, so it's a different ditch from the first part, is 0.9 meters wide. You can see that from our X direction. Here's the 0.9 with cross section as shown in figure 2. So here we've got a nice simple diagram showing a ditch width 0.9 and depth about 0.7, isn't it? Notice that they're using distances as negative as we're going down. Okay, I'm going to give us two parts to this question for us to answer. With X and Y axes as shown in the figure above, that's pretty clear. The curve of the ditch may be modelled closely by, and here we've got a polynomial. Okay, so they've asked us to model, and they're giving us and telling us it's a model. That's quite important, and you'll see the term coming through model throughout the question. So they're doing an actual figure they're going to give us, and they've got a model figure. Okay, so A, the actual ditch is 0.6 meters deep when X equals 0.2. So just having a quick look at our diagram, that's slightly over here. There's the 0.2 point. So we've got something that looks around here, isn't it? So they're telling us the actual depth there is about 0.6. Yep, negative, because it's a hole in the ground. And then it says calculate the difference between depth given by the model and a true depth for this value of X. Okay, so that's our first part of the question. So let's have a look. So part A for us. So part A, they're asking us to find the difference between the depth as given. So we know that the actual depth, so when X equals 0.2, they've told us that the actual depth is 0.6. They want us to compare it with the model depth. So comparing with the model, so the model we can find out by putting X equals 0.2 into the model. There's our Y, yeah. So that's 3.8 times 0.2 to the 4. And we're going to go, you would go through, wouldn't you, and fill in all the way. Cubed plus 7.7, 0.2 again, squared this time, and then 4.2 times 0.2. Okay, and if we calculate that through by fitting that in, we get minus 0.580, and I'm quoting that to 3 significant figures. That seems to be a typical MEI standard, and that would be suitable in the circumstances. So we've worked out now what the model depth is, and we've got the actual depth, and it asked us what the difference is. So what have we got as the difference between 0.6 and 0.580? So the difference is equals 0.02. And that will be 0 to 3 significant figures. And what units are we in? Well, we're operating in meters, and we're doing that to 3 significant figures. And the model, what's the model doing? Actually, it's underestimating, the depth, isn't it? It's only estimated at 0.58. So I should have written model underestimating depth compared to the actual. Okay, so that was pretty straightforward. They usually give you an a part of the question where you are taken through finding a point and comparing an actual or something like a lorry going through the hole, or along the ditch or something like that, comparing that to the model. So that's a typical step they're going to ask you to do. Okay, let's have a look at the second question, B. And they're saying they're pretty clear here, aren't they? Here we are, we're in find that integral. So what are we doing there? We're finding the cross-sectional area through integration, and hence estimate the volume of water that can be contained in 50 meters. So that's the secondary part. So the first thing we've got to find is the area of the cross-section. Okay, so what's that integral going to be? The area is going to be the integral of, what was it, 3.8 x to the 4 minus 6.8 x cubed plus 7.7 x squared minus 4.2 x, and that's dx. This is a definite integral. We're finding the area in that tube. They didn't actually give us the figures for the upper and lower bounds, but we can see here that our lower bound is x equals 0, and our upper bound was the full width here, isn't it? We're doing the full width of this ditch, so the upper bound is 0.9. Yep. So let's put those into our formula, our description. So there we go. That's pretty straightforward. Make sure you get that right. Check you've put the right figures. Okay, that's nice and neat and following all the right notation there. So what are we going to do next? Well, we're just going to go through and integrate this function, polynomial. So what do? Power goes up 1 and we divide by the power, the new power. So here we have again x to the 4 over 4 plus 7.7 x cubed over 3 minus 4.2 x squared over 2. In your square brackets, it's a definite integral, so we know what our upper and lower bounds are, and we put them on the top and bottom, the right hand end of the square bracket. Here they're giving us a nice one, haven't they, in that we would move on to our 2 bracket format. So our first bracket will be the upper bound, and then we'll be taking away the figure from the lower bound. But in this case, x is going to be 0 for the lower bound, so our second bracket is going to be 0, so that made life easy for us. 3.8 over 5 times 0.9 to the 5 minus 6.8 over 4 times 0.9 to the 4. So pretty quick here, isn't it, to work this through. Worth writing it out so you don't make any mistakes, because in a minute you're going to have to carry out the calculation. So all we did was substitute all the numbers in, the 0.9 in throughout into our new figure, and what we get coming out is 0 in your calculator, because you're entitled to use that in the exam, 0.496 meters squared to 3 significant figures. Here we are. Again, I would advise at this point that you do a quick cross-check What's our cross check going to be? We're going to use, we will just quickly create ourselves an approximate rectangle of the same area. So what's our, going back to our little diagram here that they gave us, what's the width here? Well, the full width is our 0.9. What's a rough, if we made a rough estimate here of it making it into a rectangle of the same area, I'd probably put something around there, make a rectangle that look a bit like that. So what have we got? That's about 0.5, isn't it? So what have we got? We've got a rectangle of 0.9 as its width, and about 0.5 is its depth, and therefore the area of that is 0.9 times 0.5, which would give us 0.45 meters squared. Yeah, so we're in the right order. We haven't made, that's just checked for us, we haven't made any silly numerical errors, because that's the sort of thing you can easily do in these sorts of questions. In the heat of the moment is calculate it out incorrectly. Okay, and what was our final part here? The final part they want us to do was, let's come up, was hence estimate the volume of water that can be contained in a 50-meter length of ditch. So what are we doing here? Well, all they've asked us to do in effect is, here's our ditch, we've got our cross-sectional area here, haven't we? We worked out that on, and here we're now going to have a length, yeah, a length of ditch. We've got a cross-section there, so the volume of the ditch is going to be the area of the cross-section times the length. So here we're going to have our figure, which we got as 0.496, and we're going to multiply that by 50. That's the length of it, meters and meters long. So we're going to come up with 24.8 meters. That's cubed, and that's the three significant figures. There we are. Not a particularly difficult question. The risk is that you don't do your calculations correctly, really. That you firstly got to recognise you're going to integrate, and the second thing is you've got to do your calculations correctly. Okay. It's a quick summary of my key points for this part of the question. So they will give you a model in these questions. It will typically be a polynomial. You're going to calculate the area by integrating the polynomial. You've then got to pick your upper and lower bounds for your extreme values of x and substitute in and calculate out. It's always worth checking your calculation by having an approximate rectangle, yeah, with the same width and an average sort of depth. Make sure you're in the same order, so that you haven't got one where your approximate rectangle says the area should be 10 meters squared and your answer is 100. That's a bit of a giveaway that you've done a calculation error. Always worth it to do. And also just check your units. Usually they'll be consistently in meters squared, or they might be in centimeters, but just check they haven't put a combination in. Make sure you quote therefore if it's in meters cubed for a volume, or meters squared for an area. There we go. I hope that's of use to you, and best of luck.